Hi there guys, in this video we're going to have a look at sequences, but really looking at a real life context that's going to, you know, I think at the end of this lesson you're going to feel quite sad, which is not my intention, but you're going to realize actually to move out and buy your first property, how much kind of money you're going to have to save a month, and then you can work out how much you're going to need to earn, and it's pretty scary. So let's look at this scenario. You can afford to save £200 a month into a saving account. The saving account is going to give you 2% interest per annum. That's what PA stands for if you don't know. Per annum, per year. Which is paid at the end of the year. So how much is in your account after 5 years? And our goal is to raise £20,000. You know, that's a small deposit on a house, but you're talking like a 2-bedroom house. Right. So this is the problem with this question is two things. We've got interest being paid at the end of the year, so I'm just going to do that again. End of the year, and we can save £200 per month. So what actually we can save is 12 lots of that. So we can actually save 2,400 per year. Okay, so that's not too bad. You know, you've taken out all your spending money and socialising, whatever. But that's how much you can save per year. But the bank account is 2%, which at this current climate we're in is very generous. You'd bite their hand off at that. And it's way more complex than the compound interest problems you had when you were younger. So let's have a look. Excuse me. So the end of year one. Okay, what's going to happen at the end of year one? Well, we've put £2,400 in, and the bank are going to pay us an extra 2%. Thank you very much, bank. I'm not going to work that out. End of year two. Well, at the end of year two, we've got more than this. And this is why it makes it a little bit more of a complex problem, because what we're actually doing is popping in, we had that at the start of year two, but we've actually popped in this. We popped in another 2,400. And what the bank are going to do is now times that by another 1.02 to give me 2% interest. So let's expand this. So we've got two terms being multiplied as just a basic expansion. So we've got 2,400 times 1.02 plus 2,400 times 1.02 squared. You know, pause the video at any point just to make sure you're completely understanding everything that I'm saying here. Let's look at another year and see if we can identify a pattern. So end of year three. Well, we've got all of this at the start of year three, so let's write all of that. So we've got 2,400 times 1.02 plus another 2,400 times 1.03. Oh, getting a bit too ahead of myself there. So that's what we've got, but we're actually adding in another 2,400. And the bank are going to pay us another 2% interest. So we end up with 2,400 times 1.02 plus 2,400 times 1.02 squared plus 2,400 times 1.02 cubed. And by now, hopefully, you've seen a pattern. So I'm just going to try and shrink this down. There we go. So let's try and write a general formula for this. So the end of year n. Okay. So for this scenario, keep it this scenario, but for year n. So we're going to have 2,400 times 1.02 plus 2,400 times 1.02 squared plus 2,400 times 1.02 cubed plus, and that's going to continue all the way till we have however many years we want to. Okay, so that's pretty good, but we're not going to always, well, do you know what, sometimes I would work it out like this because I just can't remember the formula. But let's have a look about how we can simplify things a little bit more. So we've got repeated factors to each term, so it makes sense, doesn't it, to factorize. So that'd be 2,400. And then what we have is 1.02 plus 1.02 squared plus 1.02 cubed all the way up to the very last year. Well, when you look at this, you should notice something. You need to link this to what we have been studying in class, and you should be able to see that this is now a geometric sequence, or I should say series. It's a geometric series, whereby A, the first value, is 1.02, and R, the ratio, the common ratio, well, all we're doing is this term is being times by another 1.02, so that's the common ratio. So we can actually use the formula, sum of n terms is A. Now, R is bigger than 1, so we're going to go for this one. So that means it's going to look like this, R to the n minus 1. And what that will do is work out this part of the bracket, and then we're going to times it by the amount we can afford to invest a year. Right, so let's actually work this out now for 5 years. So after 5 years, so let's write this for 5 years. So it's going to be 2,400. So A is 1.02. R is 1.02. We're going to raise that to 5 years. Take away 1. And R take away 1 is 0.02. So let's just type this in our calculators. If you can pause the video, do it as well. But you don't need to pause it because it's going to take me a little while too. And you actually would have £12,739.49. And that's just from saving 2,400 a year yourself. So 2,400 a year times 5 is 12,000. So actually the bank, they're only giving you £739, but hey, that's decent money not to be sniffed at. Alright, but part B was we need to make 20 grand. We need to have a deposit for a small, tiny house in Petersfield. So 20,000 is what we need. So we've got 2,400 lots of 1.02 times 1.02. We don't know how many years now. That's the question. How many years is it going to take us? Take away 1 all over 0.02. So we just have to rearrange this. The first thing I'm going to get rid of is the 2,400. So I'm going to do that now. 20,000 divided by 2,400. And that's, so that's 25 over 3. Okay, so what I'm going to do now, I'm just going to get it all the way down just to here. So I'm going to times by 0.02. I'm then going to divide by 1.02, and then I'm going to add 1. And I get that to be 178 over 153. Now we're going to take logs. Take logs to both sides. I'm going to use natural logs because I have to press one less button on my calculator. So that's going to be n lots of natural log of 1.02. So let's do that. So you've got a natural log of my answer divided by the natural log of 1.02. Don't know why I have 2 equals there. So it takes you 7.64 years. So basically 8 years. So you're going to have to live at home for 8 years if you can afford to save that much. And you've got a good account like that at 2%. So 8 years really. You're not going to be able to do it at the start of the 7th year. The interest is paid at the end of the year, so it is actually going to be 8 years. Right, so there's lots of modeling sequence questions, but I thought this lesson, what we're going to do is just focus on that. Okay, focus on this real life context. So there's actually only one question in the book I can give you, but I'm going to make up one for you to do. Alright, best of luck guys.